the children, welcome to Zero Panic Maths. Let us continue our discussion on the concept of arithmetic progressions in this session also. So in the previous couple of sessions, we have seen how to find the nth term of an arithmetic progression. Okay, so I hope you have watched all those videos because the knowledge on that is must required here in understanding the concept of how to find the sum of first n terms of an arithmetic progression. Okay, so now let us consider the example that we have seen in the beginning of this chapter. Okay, so there was an example, real life example, which created a list of numbers and that represented an arithmetic progression. What was that example? Okay, assuming that Sakila puts 100 rupees into her daughter's money box. Okay, when she was 1 year old. When she was 1 year old, her daughter Shakila puts 100 rupees in her daughter's money box. Okay, and increased that amount. Okay, she went on increasing that amount by rupees 50 every year. So next year she put 150 rupees. To that next year she put 200 rupees. So every year she went on increasing 50 rupees, starting with 100 rupees. So you know that in the beginning of this chapter only we saw that, okay, so this real life problem can be represented as an arithmetic progression like this. Okay, in the box, if you see the money for the first, second, third and fourth birthdays, these were respectively like this. What would be the total money collected when her daughter becomes 21 years? How do you calculate the total money? Okay, how do you calculate? You go on adding each and every value from every year, right? 100 plus 150 plus 200 plus 250, and how goes on increasing. This amount will goes on increasing by 50 till 21 terms. Okay, so till 21 terms you have to go on incrementing 50 50 50 and add all of those. Okay, is this the feasible solution that looks to you? Okay, this is not a feasible solution because this, first of all, this is time consuming and even it is complex also, it is tedious also. Okay, so what we will do is we will create a procedure or we'll create a formula so that this job becomes easy for us. Okay, adding the sum of first n numbers of any given series. So this is what the need of this sum of the first n numbers of an arithmetic progression. Okay, now before we actually go for deriving that formula, let us see one of the way that you calculate the sum of positive integers from 1 to 100. So assume that s represents the sum of the numbers from 1 to 100, and I will write s is equal to 1 plus 2 plus 3 plus 4, that way till plus 100, right? Assume this. Okay, now suppose if you reverse the series, what's the list? Okay, reversing the list. What I'm doing here is reversing the list. So that also is considered as a yes only, because that will not change, right? The value will not change. So that is 99 plus 98 plus 2 plus 1, right? This sum remains the same. What we did is we just reversed it and did the same sum of 100 to 1 numbers. Okay, now add both the series. If you add both the series, the first term to first term, second term to second term, third term to third term, that way if you go on adding both, so suppose I call it as equation 1 and this as equation 2, adding both equation 1 and 2, what happens? Let us see. Adding 1 and 2. Okay, s plus s, what is that? S plus s at the left hand side. Right hand side, add term by term. Okay, term 1 of the first series with term 1 of the second series. So what is this? 1 plus 100, it is 101, plus 2 plus 99, that is also 101, plus 3 plus 98, that is also 101. So if you go on continuing this way, every nth term of first will be added to the nth term of the second series. You are going to get 101 as the sum. Term wise I'm adding. Okay, let us see what happens. So finally at the end also, 100 is the last number in the first series and 1 is the last number in the second series. That will also give me 101 only. Is it not? Okay, now tell me how many 101s are there. Now how do I add this? I should be having a easier method to add 101 also, right? Okay, so how many times 101s are there in this series? 100 times, right? Because the numbers, we know that the numbers are from 1 to 100. So totally 100 times 101 you are adding. So can I write like this 100 times 101? Okay, so this sum is actually 100 times 101. Okay, so that is the reason it will become 2s. Okay, s is actually the sum of 1 to 100. Okay, yes, what we considered is the sum of all the numbers from 1 to 100 positive integers. Okay, it is 2s is equal to 100 into 101. So what is s? S is equal to 100 into 101 divided by 2. So 2 ones are and 2 fives are, it is 50. So what is 50 finally? 50 into 101, right? And what will be the value, the sum value? If you 50 into 100 is actually 5000 and 5050 it is. See how easily we got it, how easily we got the sum. It is the one of the simplest way that we can calculate the sum of positive integers from 1 to 100. So any numbers given, if you reverse it, add both the lists, then you can easily find out the sum. Okay, now let us follow the same procedure to find out for any arithmetic progression given. How can I find out the sum? Let's move further to find out. We will use the same procedure. Okay, using the same method to calculate the sum of first n terms of an AP. Okay, now let us assume, let a plus d, right, and a plus 2d, these are the terms of an arithmetic progression in general. Okay, and we know that at last it will be a plus n minus 1 into d. This is the nth term, a plus n minus 1 into d. That is the nth term of any arithmetic progression. Okay, now let us assume this as yes, right? This as yes, that is sum of n terms of any arithmetic progression in general. You understood this? Okay, now what is the next step is reversing the series, reversing the list. Okay, reverse the list. What happens is s is equal to, it remains as s only, and a plus n minus 1 into d comes in the beginning. Okay, a plus n minus 1 into d, this is the first term. Okay, now what is the second term? It is just previous to this term. If it is n minus 1, it will be n minus 2, right? Because it is one less than the term that is multiplied with difference d. You remember this? Okay, so it will be n minus 1. Hope you understand this. Okay, a plus n minus 2 into d, right? So this way if you go on, finally you will have a, because I have reversed it, right? A, this is the reversed way of the sum of n terms of an arithmetic progression. You getting it? Okay, now what is the next step? Next step is to add the term by term of both the lists, both the arithmetic progression. So here adding 1 and 2. Okay, assume that the first two equations that we consider as equation 1 here and equation 2. This is equation 2. right? Okay, so adding 1 and 2, what we will get is s plus s is equal to, see, okay, listen to me carefully here. It is, there is one a here and there is already a plus n minus 1 into d plus a. It will be adding a to this term, okay, adding a to this term. So that will actually get add another a to the first term and the remaining terms remains the same, no difference at all. So what I will get is, it is 2a plus n minus 1 into d. Okay, it is 2a. Now similarly, if you add a plus d here, see how many n d's are there? N minus 1, sorry, n minus 2 d's are there. If you add one more d to this, this will actually turn into n minus 1 only. Okay, because it will be nd minus 2d, minus 2d plus d, it is minus 1d, right? Okay, so that will be n minus 1 and a is added to this, so it will actually get repeat the same term. What is that? 2a plus n minus 1 into d. It will repeat the same term again here. Hope you're getting this. Okay, so every first term to first term, second term to second term, if you go on adding this, finally what we are going to get is again a plus a, it is 2a and the remaining is n minus 1 into d. So this is the term that is getting repeated every time. And how many times it is getting repeated? N times. Is it not? Because you see, what we are trying to find out is the sum of first n terms. So there in the previous example, it was 100 times. It is n times. So how do we write this? This is as n times. Let me write this as n times. Okay. So if it is n times, what I will do is I will take one term. What did we do in the last? It is 101 repeated, then 100 times 101. Similarly, what I will do is 2a plus n minus 1 into d n times. I will write that. Okay, let me write that. S plus s is equal to 2s and this is n times 2a plus n minus 1 into d. Right? Then finally, what is s? S is actually the sum of n first n terms of an arithmetic progression. That is, taking 2 to this side is n by 2, 2a plus n minus 1 into d. Okay, so this is the final formula. Remember this. Okay, so to find out the nth term, this is the formula. What is that? A plus n minus 1 into d. Nth term, value of nth term. This is sum of all those n terms from first n terms. Okay, it is first n terms from one first term to the nth term. If you want the sum to be found, the formula used is s is equal to n by 2, 2a plus n minus 1 into d. Remember this formula. Okay, okay, now yes, yeah, it can be even, you can represent it as sn also, because it is sum of n terms. Okay, sum of first n terms. Hope you understood this. Okay, let us see what is next. Okay, now calculate the sum of first n terms of an AP. Okay, so sum of an AP, it is okay, it is when I forgot some important things in this formula. What are a, n and d? You should be knowing this. And what is sn also? Okay, sn is sum of n terms, as it is there here. Sum of n terms, you write it here. Sn is equal to sum of n terms. And what is n? Is number of terms. What is n? Is number of terms, right? And what is a? A is first term. A is first term. And what is this? D. What is D? D is common difference. Is it not? So whenever the first term, common difference, and the number of terms is given, then the sum of n terms should be calculated by using this formula. Let us just modify this formula little bit so that when only the first and last terms are given, there is no difference given. Okay, if D is not given and only the first and last terms is given, yes, just modify the given formula. So what is the formula that what we just derived is Sn is equal to n by 2 2a plus n minus 1 into D. Okay, now let me rewrite this, the term inside this n by 2, and this is a 2a as a plus a plus a, and this is plus n minus 1 into D. Okay, and what is this? A plus n minus 1 into D. That is the formula to calculate nth term. And what is that nth term? an. What is that? an. So you can say it is n by 2 a plus an. That is the nth term. So in that case, you can just replace that by this formula. So when first and last terms are given, everything same, n by 2, instead of this inner term 2a plus n minus 1 into D, the a 1a from this you give it to the last term and make it an. Okay, it is a plus an. That is first term plus last term, n by 2 will give you the sum of first to last numbers. This is the modified formula. Remember this formula as well. Okay, and if suppose if only n terms are there, okay, if you can little bit modify this also. If only n terms in AP, okay, then actually what is that? An is equal to L, or last term is equal to an. L, if you represent this as a last term, okay, this you can assume it as last term. Okay, L as last term. So then simply I'm just modifying this. Sn is equal to n by 2 a plus L, where a is first term and L is last term. Okay, anything you can remember. Okay, just a simple difference that an is actually nth term. Okay, if that nth term itself is the last term, then it is the modified formula. Let us now coming back to the problem of finding the total amount of money collected. Okay, so we in the beginning of this session we started with a problem. Okay, you remember that problem? What was that problem? 100 rupees money Shakila was putting in her daughter's money box, and she went on adding 50 rupees every year to the initial amount, and that was this amount, right? And this went on to how many terms? It is 21 years. That is 21 terms. You can say 21 terms. So what was our problem? You remember what was our problem? What will be the total amount of money at when her daughter becomes 21 years old? So there will be 21 such terms. I don't know what is the 21st term. Okay, but I want the sum of all this money added 21 times with an increment of 50 in every term. Okay, this is what my problem is. Okay, and we had a formula. Okay, now here what are given and how can I make use of the formula that we just derived. Okay, here what is A? A is the first term, that is 100. What is D? D is the difference that is there between the first and the second term. What is that difference? Difference is 50, right? And what is N? A, D, N are must required to calculate the sum. And what is N? N is 21, because that is 21 terms. Number of terms. N is actually number of terms, right? So 21 years they wanted, means N is equal to 21. Hope you understood this. Okay, now since we know the formula, I will write that formula once. Okay, next time onwards you should be remembering this formula. Sn is equal to n by 2, 2a n minus 1 into d. Right? Let us substitute all the values. So it is actually S21, sum of 21 terms. It represents sum of 21 terms of this arithmetic progression. Okay, what is n? 21. 21 divided by 2. Okay, 2 multiplied by, what is a? It is 100 plus 21 minus 1, and what is d? D is 50. Right? Okay, now let us keep 21 by 2 as it is and see what happens inside. 100 into 2, that is 200, plus it is 21 minus 1, it is 20. Okay, 20 times of 50, it is 1000. Right? So it is 1200. 21 multiplied by 1200 divided by 2. Right? 2 ones are 2, 600 it is. Okay, so now 21 times of 600 is what our answer will be. Okay, and what is that answer? Let us calculate that. Okay, 6 ones are 6 and 6 twos are, I'm just multiplying 6 to 21. Okay, 6 ones are 6, 6 twos are 12. Okay, and 2 zeros I'll be keeping. So what is the value at the end of 21 years? It is 12,600. So you can write that conclusion. So therefore, total money collected when her daughter becomes 21 years old is 12,600 rupees. Okay, you understood this formula? Okay, so let us see some of the examples based on the same formula and derive different sums. Okay, now find the sum of first 22 terms of this. So they are directly given here that it is a, what is d, and what is n. 22 terms they are saying. You don't have to say let. Here a is equal to 8. That is the first term. Okay, and what is d? D is the difference between second and first, or third and second. It will be same only because they have given it as an arithmetic progression, so you don't have to worry about that. Okay, 3 minus 8, and what is that? It is minus 5. Minus 5 is d, and since they have given it as 22 terms, we know that it is going to be the sum of 22 terms. Okay, and what we need is S22. It is S22. I'm not going to write that formula again and again. You need to write that formula if you need it. Okay, so therefore S22 is equal to n by 2. What is n? N is 22. Okay, n by 2, and 2a, what is a? It is 8, plus n minus 1, and what is n minus 1? It is 22 minus 1, and into minus 5, that is d. Right? Okay, now it is 2 ones are 2 11s are. If it goes, you can always cancel it out. Okay, it is 8 2s are 16. Okay, so I cannot do this as plus because it is going to be minus. Okay, it is 21, right? 21 and minus 5. 21 minus 5. Okay, it is going to be minus 5 ones are 5 and 5 twos are 10. That is minus 105. Right? Okay, what is 16 minus 105? It is 95 and 89. Right? 11 multiplied by minus 89. 11 multiplied by minus 89. 11 nines are 99. It will be minus only. 11 nines are 99. 9 here. 11 eights are 88. 88 plus 9, that is 97. Right? 97. Is it fine? Okay. So this is S22. That is, let's move to the next problem quickly. Okay, 12. If the sum of first 14 terms of an AP is 1050, they have given S14. See, here they are given with the sum. Okay, the S value they have given. Okay, and what we need to find out is, and its first term, that is a, first term is a, and what is this? It is S14. S14 they have given. Find the 20th term. We have to find the 20th term here. So to find the particular term, the formula used is the previous formula only, a plus n minus 1 into d. Okay, to find nth term. Okay, so here d is not given, only first number is given and some is given. Okay, yes, 14 is given. With that information only we need to find out d, because d is needed to find out any nth term, right? Any nth term, if you want to find out, you need d for that. Okay, so let us find out d with given information first, and then find out a20. Okay, by a plus n minus 1 into d. Simple, right? So here what is given here? S14 is equal to, what is that? Sum of, for first 14 terms, that is S14, right? S14 is 1050. They have given it as 1050. And what is A? A is 10, the first one. Okay. And what we need is A20. Okay. What we need is A20. But before that, we need d also to calculate a20. So let us calculate d first. Okay. So we know that the SN formula. Okay. Substitute S14. S14 means n is equal to 14 only here. Okay. You have to write that also. If it is S14, then n is 14 terms. Right. They are already told that first 14 terms means n is equal to 14. Right. If n is equal to 14, n by 2 and 2a. What is a? A they have given it as 10, right? A is 10 and n minus 1. So let me write this as 14 minus 1, 13. Can I write directly 13? Okay, that is 13 into d. Is it right? So d value we don't know. We have to calculate that only. Okay. Now, what is S14? S14 also, they have given it as 1050. So, let us substitute that also, 1050. Okay. And 2, I will take it to the left side. It will multiply them. Okay. And I will keep 14 here only. And inside the bracket, it is 20 plus 13d. Right? 10 into 2. 20 plus 13d. Is it fine? Okay. Okay. Let me write it correctly. 20 plus 13d. Okay. So let us take 20 plus 13d. First, I will just swap this just to make it simple. Okay. It is 20 plus 13d is equal to, I will take 14 also below. It will be 1050 into 2 divided by 14. Right? Okay, so 2 ones are 2, 2 sevens are, it is 14. Okay, 7 ones are, and 7 ones are 7, 3 remains here, 7 fives are 35, and it is 150. Right? It is 150. So 13d is equal to 150 minus 20. I will take to that side. So that makes d is equal to 130 divided by 13. So this 13 I will take this side. So what is d then? D is equal to 10. 13 tens are 130. So now we know that what is a, what is d, what is n. N is 14. I can calculate 20th term. Okay. So the second part of this is, now a is equal to, what is a is equal to 10, d is equal to also 10. Okay, then and n is equal to 14, sorry, n is 20, right? N is 20. They want 20th term. Okay, so I need a20 is equal to 0. Therefore a20 is equal to A20 is equal to A plus n minus 1 into D, that is 10 plus n minus 1, that is 20 minus 1 into D again, that is 10. So that is 10 plus 19 into 10, that is okay. So A20 is equal to, sorry, 190 plus 10, sorry, it is 200. Okay, 19 into 10, 190 plus 10, that is 200. So what is 20th term? Therefore 20th term is equal to 200. This is what the solution. So with the given information, what is missing, you need to find it out first to find out what is required. Okay. Okay, now let us move to the next problem. How many terms of AP? Here, how many terms? Whenever I told you that whenever it is asked how many terms, then it is n. Okay, we need to find out n. How many terms of this AP must be taken so that their sum is 78? So that their sum is 78. So they have given Sn. Sum is Sn. Okay. So here Sn, we don't know what is n. That is why I'm writing it as Sn. What is Sn? Is 78. And what is A is the first term. Okay, always first term. And what is D? What is D? Is 21 minus 24. That is minus 3. Okay, we don't know n. So what is required here is n only. Okay, now substitute when A, D, Sn are given, I should be able to find out n by using the sum formula. Okay, so what is Sn then? Sn, okay, let me write that for just remembering it. N by 2 and 2a plus n minus 1 into d. Okay, let us use this formula and substitute Sn. What is Sn? Sn is 78. We don't know n, so that is what we are going to calculate. So n by 2, and we know a, that is 2 into 24, right? Similarly, we don't know n. I am keeping it as n minus 1, and we know the value of d, right? Okay, now okay, let us take 2 to this side first. 78 into 2, just to make it simple. Okay, keep n outside and say it is 48, and this is minus 3n plus 3, right? I'm multiplying minus 3 to n minus 1. Okay, so that will be 48 plus 3, which is 51. Okay, so it is what is this? Let me multiply n to this, or first of all let me write this 48 plus 3 first. Okay, that is 51 minus 3n. Okay, is equal to, what is this? It is 156. It is 156. Okay, let us multiply n and swap this first. Okay, yeah, n, that is 51 n minus 3n square, minus 3n square is equal to 156, right? Okay, now it is going to be a quadratic equation. 3n square plus 51n, I'm writing it in the form of ax square plus bx plus c. Okay, writing n square term first and then plus 51n, and then this minus 156, I'm taking it to the left side to make it minus 156. Okay, is equal to 0. So multiply minus throughout and divide by 3 also, or divide by minus 3. Divide by minus 3. You can say divide it by minus 3. Divide by minus 3. What you will get is n square, and this is 17, right? 17 3s are 51. It is minus. This plus is going to be minus, that is, sorry, this is 17n. Okay, and this minus will become plus, and this is 3. Okay, 3 4s are 12 and 3 remains 3. Okay, sorry, 3 5s are 15 and 3 2s are, okay, 3 5s are 3 2s are is 52. Is it fine? Is the quadratic equation we got is n square minus 17n plus 52, right, is equal to 0. Now what remained is to find out the factors of this quadratic equation by splitting the middle term and find out the value of n. Okay, so that is 52 is the product, or 52 n square you can say. So 13 4 13 4za, okay, 13 4za will be the value for this. Okay, 13 and 4, 13 4za, okay, and 13 minus 4 will be this. Okay, so let me write this as n square minus 4n minus 13n plus 52, okay, is equal to 0. Okay, now take n common, it will be n minus 4. Take 13 common, it will be n minus 4, because 13 4s are only 52, okay, is equal to 0. Again, you know that the quadratic equation factors n minus 4 common, and what remains inside is n minus 13 is equal to 0. So n minus 4 is equal to 0, or n minus 13 is equal to 0. So therefore n is equal to 4 or n is equal to 13 is the value for n. How many terms? Okay, they are asking how many terms of this AP should be summed up to have the sum as 78. But you got two different values here. Okay, one is n is equal to 4 and n is equal to 13. But what we know is if n is a positive integer, then only we should be considering that value, right? But both are positive integers. So what does it mean is sum of first four terms is also 78, and sum of first 13 terms is also 48 in this case. Okay, this is a peculiar case where both are the actual values only. You can verify it. Okay, now example 14. Find the sum of first 1000 positive integers and first n positive integers. So in general, first n positive integers and given first 1000 positive integers. Looking into the first problem, okay, what you can say is it is s 1000 that is required, right? A sum of first 1000 positive integers they are saying, and what will be the term, what will be the list of terms? It will be like this, right? 1 plus 2 plus 3 plus till 1000 is the last term. So here what they have given us is they have given the first term a and the last term, that is 1000. So if the first and last terms are given, though there is a d given here, we have a reduced formula, we have a simpler formula for calculating the sum, and what is that? Sn is equal to n by 2 and a plus l. You remember this formula? When first and last terms are given, it is sufficient to use a simpler formula for this. Okay, let us substitute n. And what is n? N is 1000. We know that. Okay, n is 1000. And what is a? A is 1. Okay, and l is also 1000. Right? Okay, so it is 500. So 500 into 1001, 1000 plus 1 is 1001. So what is the first sum of first 1000 positive integers is 500 and 500. So it will be 500 500. You see that this will be the sum. Okay, okay, now let us see what will be the first n positive integer. See, they have given 1000 positive integers. In place of 1000 you put n there. Okay, in general formula they want. Okay, so it will be like let Sn is equal to 1 plus 2 plus 3 plus, what is the last number? It is n. Okay, again use the same formula here. Okay, it is similar problem. A and L. What is L? L is n here. L is n. Substitute the same formula, write the same formula over there also. Therefore, Sn is equal to n by 2. Okay, let me keep this as n by 2 only. Okay, and what is A? A is A only, or A is 1. Okay, let me write that. A is 1. A plus L. What is that? L is n. Right? L is n. So I can write it that n into n plus 1 divided by 2. So sum of first n positive integers is always n into n plus 1 divided by 2. You can remember this also with given terms only. If there are how many terms given, then some of the first n terms can be directly derived from this formula also. Okay, let us quickly move to the next problem. Okay, find the sum of first 24 terms of the list of numbers whose nth term is given by this. Okay, they have given us the nth term. We have to first just write out the arithmetic progression and then find out the sum of 24 terms. Assume this as equation 1. Now, given this as an, what I can do is let a1. So let us put 1 in place of n. What happens? 3 plus, it's simple only. Okay, 3 plus 2 into 1. What is that? 2, 3 plus 2, that is 5. Okay, what is a2? Second term of the arithmetic progression. Why I am doing this? Because I want a and d, the first term and the common difference. Okay, it is again in place of n you just put 2. Okay, 2 into 2, that is 4 plus 3, which is 7. Okay, what is a3? What is a3? It is 3 plus 2 into 3, that is 6 plus 3, that is 9. Right, because this is the nth term they have given, I can derive any term given nth term formula. Okay, so therefore you can say the first term a is equal to, what is that? 5. Okay, and d is equal to a2 minus a1. I can say a2 minus a1, that is 7 minus 5, which is 2. Okay, and what is required is S24 in our case. S24, in which 24 is actually n for us. Okay, so therefore S24, that is sum of first 4 terms of this. Okay, that is 24 divided by 2. It is 2a. What is a? A is 5. Okay, and n minus 1, that is 24 minus 1. Let me write that. Okay, it is 2a plus n minus 1 into d. What is d? D is 2. Right? Okay, again 2 ones are 2 12s are. Okay, keep it simple. 12, and inside the bracket it is 10. Okay, and it is 23 into 2. It is 24 minus 1, 23 into 2, that is 46. Right, 46 plus 10, which is 56. 12 into 56. Okay, so finally sum of 24 terms is 12 6 are 72. Right, 12 6 are 72. 7 here, 12 5 are 60, 67, which is 762. 762. Let us, this is the formula. Okay, let me write it clearly. 762. Okay, let's move to the next problem. Okay, So it is the 16th example in which there are three different sub problems. Okay, and it is 1, 2, 3. We will solve it in slide by slide. Okay, so let us read the problem. A manufacturer of TV sets produced 600 sets in third year and 700 sets in seventh year. Okay, so third year, that is what is third year means the third term. Okay, you can say A3. Okay, and 700 sets in seventh year means A7. So what is given here is here A3 is equal to 600. Okay, that is the TV sets produced in third year. So one term value they have given. Okay, A3 and A7, right? That is A7. A7 is equal to 700. Let us see what we can derive from the given equations. Okay, it is A7. Okay, seventh year. Assuming that the production increases uniformly, this is very important. Production increases uniformly. It means there is a fixed value that incremented every year. Okay, a fixed number every year there is a increment. And what all to be found is the first one, the production in the first year. We have seen such problems in the previous sessions. A plus 2d is equal to 600. This is from equation 1. This is A3. Okay, A3 is A plus 2d. What is A7? It is A plus 6d is equal to 700. Right? So solve these two equations to get both A and D. Okay, then you can, when A is found, that is the answer for the first year. Okay, the production in the first year. You understood this, right? Okay, now subtract 1 from 2. Okay, you can say equation 2 minus 1. Equation 2 minus 1. Okay, what is that? A plus 6d minus A minus 2d is equal to 700 minus 600. Right? It is A got cancelled. 6d minus 2d, which is 4d, is equal to 100. So therefore D, what is D? D is equal to 100 by 4, which is 25. So D is equal to 25. So what is that fixed increment that is getting every year is the production increases uniformly by a fixed number. What is that fixed number? Is 25. Okay, every year 25 increment will happen. Let us see that. Okay, now substitute this value of D in equation 1 to get the value of A. Right? From 1, what I will get is A is equal to 600 minus 2D. Right? 600 minus 2D. And what is that D? Let me replace that D by 25. That is 50. 600 minus 50. So what is A? That is 550. So the first year production in the first year is 550. Let us move to the next. Okay, it is the same 16th problem, but the production in the 10th year we want here. Okay, 10th year production is actually A10, right? Production in 10th year is A10 is what it is required. So with n is equal to 10, because it is A10 they want it. Okay, and we know that D is 25 and A is 550. We know that, right? Right? Okay, now let us find out what is AN then. A10. A10 is A plus, that is 550, plus n minus 1 into D, that is 10 minus 1 into 25, right? Okay, it is 550 plus 9 into 25. 9 into 25, that is 225. So 550 into plus 550 plus 225. So this is the value of production in 10th year. Okay, add it out. It is 775. 775. So production in 10th year is, you can say, you can write that statement. Production in 10th year is 775. Okay, let us see the next. So this is the third sub problem of the example 16. Okay, so the total production in first 7 years. So they are asking the sum here. Total production means sum. Okay, first 7 years means S7 they want it. Okay, remember this. So here A is equal to, what is A? We have already derived, that is 550, and we know that D is 25, right? D is 25, and 7 years means N is equal to 7, right? And what they want is sum of the production. The total production means sum of production in every year, first year plus second year plus third year, that way 7th year till 7th year, what is the production. So that is what the S7 is. Okay, S7 is 7 by 2. Okay, it is N by 2. 2A, that is 2 into 550 plus N minus 1 into D. Okay, let me write that 7 minus 1 into 25. Right. So let us keep it as 7 by 2 into bracket. It is 1100 plus 6 times 25, that is 150. Okay. So it is 1250. Right. So 7 by 2 multiplied by 1250. It is 2 ones are 2 sixes are 2 twos are and 2 fives are 10. So what is this? Is 7 into 625. Okay, 7 fives are 35. Let me write that. 7 fives are 35. 7 twos are 14. 17. Okay, 14 plus 3, 17, and 7 sixes are 42 and 43. So what is that? S7. So the total production, you can write that also yourself. The total production in first 7 years is 4375. Okay, so let us stop our discussion here only. So in the next session we will see the problems based on the exercise problems 5.3. okay, these are also the problems that are based on the sum formula and the nth term formula also. Okay, so we will see different problems based on the whatever we have discussed in today's session. The same kind of problems we will see in the next session as well. Okay, thank you.